Hello, everyone. Thank you for joining Did You Know, the ESCO HVAC podcast. This episode brought to you by Heatcraft, the market leader in commercial refrigeration. Learn more at heatcraftrpd.com. Justin Bailey, technical trainer from Heatcraft. How are you doing today, sir?
I'm doing wonderful. It's a beautiful day here in Stone Mountain, Georgia, pouring rain all day, so I'm glad I'm inside.
Exactly. Yeah, I think we had some rain earlier today, and it's going to be hit and miss all day. Spring weather. It's part of it.
But it's better to be here than out on a roof somewhere today.
I agree. And that's one of the fun things about regrouping and talking with experienced technicians like yourself, Justin. Before the podcast, we were talking about, our experience in the industry. Both of us were refrigeration technicians. I spent a majority of my life in the field. You as well were, refrigeration technician. We've both seen some refrigerant transitions early in the industry when we were going away from things like CFCs and HCFCs. One of my biggest hiccups back in the day is when we were going away from R12. So when I got into the industry, I was working on I was still a young tech, and I was working on a lot of mom and pop grocery stores and restaurants and every bar in about 5 counties. So everyone had old R12 coolers, right? And so we were going through the refrigerant transition, and some of them were easy to transition over to. So depending on what kind of control it had. So, as a technician, I had to look at a system, determine what was the existing refrigerant, whether it had a temperature control or a pressure control. Because if I was using R12 and I was going to use something like R414B, it might not work well on pressure control. And so I'd have to convert the temperature. Sometimes it was a headache. And a lot of technicians are concerned about this A2L transition that we're going through right now for commercial refrigeration, because you have, there's been some hiccups with the R454B availability in the residential light commercial sector. And so the refrigeration technicians are going, oh, is it going to be crazy for us? And not really. It's
No,
not.
I don't think so.
Yeah. When we talk about the solutions, yeah, we're going through refrigerant transitions. But when we look at the big picture of what we're doing, we are just using refrigerants to move heat. Many of our new refrigerants, if not most of our refrigerants, are going to operate in very similar pressures to what we're used to. And when you have forward-thinking companies like Heatcraft, it makes it an easy transition, whether you're working on a new system or retrofitting an existing. So let's talk about some of the changes in commercial refrigeration and solutions that Heatcraft is offering.
Okay, well, the first thing that I want to say to everyone is a refrigeration system is going to work the same way that it always has. You're dealing with heat transfer, you're using a refrigerant through it. So from that standpoint, you're not really looking at a drastic change. So keep it simple. The biggest question that I've gotten asked is, can I retrofit an existing system to A2Ls? And the short answer to that is no, because they're mildly flammable. So you are looking at potential equipment replacements. If you're going to go to an A2L, we're going to have some transition time with it. Because we're still seeing systems that, in the air conditioning side, you're still seeing systems that have R22 in them.
Oh, yeah.
So from that standpoint, I don't think it's going to be a radical change as far as the way the systems are going to work. It's, as we move into this, don't let it intimidate you, because it's not going to be, like I said, it's not going to be a radical change.
Exactly. When we think about, what are we doing? We're working with a refrigerant that looks much more similar to an A1 than it does an A3. The potential for flammability is just near impossible. I've tried my darndest and was very disappointed. But we're adding some safety measures in that. So let's think about on the commercial refrigeration side. And let's think about what obstacles we might be introducing, not even obstacles, what new perspectives are we going to add with A2L refrigerants that might look different than we did with, say, an A1 refrigerant?
Well, the biggest thing is, first, you got to understand the classifications of refrigerant. We've been using A1s. A is the fact that it's non-toxic. When you're down in the A1 range, it's non-flammable. The B refrigerants are toxic, And the higher you go up on that number, they become anywhere from A1s, non-flammable, non-toxic, to the A2Ls are non-toxic, but only mildly flammable. Anybody that's ever used a torch on a line with existing R22 and oil in it, or 410 and oil in it, it's not going to be any worse than that, because it's only going to burn if there is an open ignition source. You get rid of the ignition source, the flame goes away. So
Mhm.
the biggest thing is that when you service an equipment with A2Ls, is use nitrogen. You should be doing that regularly anyway to
You
eliminate
bet.
the oxidation. The other thing is if we move into the replacement and change out market, you're going to have to look at a couple of differences in piping.
Okay.
That's probably going to be, I think, the biggest changes, because first of all, as I tell everyone, each refrigerant's got its own amount that it'll boil away into vapor.
Hmm.
So I tell everybody, do yourself a favor, run your pipe sizing charts, make sure first of all that the piping is the correct size, because oil return is a big issue. The oil is not going to be any different with the A2Ls than the POE we've already been using.
Exactly.
So that's not going to be a big, in my mind, that's not going to be a
Hmm.
big concern. The biggest concern is probably going to have to be that we're going to have to go to a refrigerant detection system
Okay.
to shut it down and stop the refrigerant loss in the event that you have a leak. Because the difference with refrigeration is the fact that your walk-in coolers, walk-in freezers, you're in a contained area. So you're going to have to do some calculations. Fortunately, there's the ASHRAE information, ASHRAE 15 and ASHRAE
Hmm.
34 are out
Hmm.
there to help you calculate that. There's 4 or 5 different mitigation zones. So you just have to figure out which one you're in. But I think it's going to be the piping that's going to be the biggest difference in what you've been doing, because we're going to have shut-off valves and check valves outside of the box. In other words, if you have a leak in the evaporator and that refrigerant leaks in that enclosed space, you want to be able to stop that and not lose any more refrigerant. And if you have multiple evaporators, you're going to have the piping is going to have to change to move the check valves outside of the box to each individual evaporator. That way you minimize your refrigerant leaks. So I think that's probably going to be the biggest challenge that we're going to face with this.
Yeah, if we think about what are we doing with mitigation, we've been using mitigation strategy in gas-fired appliances since we came out with electronic ignition modules. A mitigation strategy is if there is the potential for a leak. Say I had a rollout limit or a pressure switch not functioning on a gas appliance. All right, what's it going to do? It's going to shut down the potential for fuel, and then it's going to run the fans to dissipate and mitigate that so that there's no potential for ignition. So if we think about a box, right? Think about a walk-in cooler, a walk-in freezer. We have a fairly small space. So if we were to have a release of refrigerant, we just need to make sure that we reduce that refrigerant as quick as possible. And so I go back to thinking about, pump down systems. Or anyone that's familiar with a pump down system is already familiar with what we're going to be doing with mitigation. It's just a different type of control that's going to operate that solenoid. So, kind of walk us through what a mitigation would look like and say a walk in cooler.
Well, as I said, there's several different mitigation zones. The
Hmm.
first one is if you have under the acceptable amount of releasable charge, which is
Hmm.
usually about 6 to 8 pounds, depending on
Depending
the
on the refrigerant.
refrigerant, and you've got a certain amount of square footage in the box, then you
Hmm.
don't really have to do anything, because
Exactly.
the refrigerant's heavier than air. It's
Hmm.
going to fall to the floor, and it's only going to build up so much. Then, of course, you have the next mitigation zone, which is circulation. If you have either the refrigerant detection system fails, the sensors don't work, and it says, hey, you don't have a leak, but I can't tell, then the circulation, the evaporator fans that are already there simply have to run to keep it from
Just
pooling,
forced on.
forced on.
Hmm.
So, and then in the next mitigation zone, that would be exactly what would happen. I've got enough in here. I don't have to do anything other than turn the fans on. And then from there, you move to the next mitigation zone, which is you're going to have to do some shutdown, and you're going to have to stop the refrigerant flow. That's where the solenoid valve and the check valve come come into play. Now, they have to be separate valves from what you're already using. They have to be rated to do that. Check valve goes in the suction line, prevents anything from the
Coming
condenser
back.
coming back.
Hmm.
The refrigerant detection system would simply shut off the that solenoid valve to stop the refrigerant flow, and the unit would pull the refrigerant out of the evaporator and shut down. And your refrigerant detection system would go off and say, "Hey, you've got a leak."
Yeah.
So then from there, you move into, you've also got a volume in between. So there's an area where the volume is sufficient to take care of it. The worst one is going to be if you move into the ventilation zone. At that point, you're going to have to introduce
External.
exhaust fans
Right.
and fresh air coming in. But for the most part, that's where if you size your walk-ins and the evaporators correctly, it becomes a one-to-one, one evaporator to the cooler. If you have multiple evaporators, you have an individual check valve and shutdown outside the box for each evaporator, because the odds of having multiple evaporators leak are not very likely. So then you would keep it out of that mitigation zone where you need the exhaust and the
Okay.
fresh air coming in. So
I like it.
understanding the mitigation zones and how they apply to the square footage of the box you're in is probably the biggest challenge.
Yeah, and it's just a little bit of a learning curve. And we're going to use calculations to quickly look at the capacity of the charge. We're going to look at the space that we're in, and then we're going to be able to determine what needs to be done. I myself love the idea of installing, the solenoid per coil plus a check valve. And if we look at some of the residential strategies, some of the manufacturers are recommending doing that even if it is below the required charge, just as a good practice. So there's ways that we can look at that, but there'll be calculations to use to determine which is required.
And anytime the manufacturer, we at Heatcraft, we put a lot of emphasis on the A2Ls and
Mhm.
training for A2Ls, because we don't want anybody to say, "Well, I'm afraid to use it," or "I don't want to use it," because we're going to move that direction.
Absolutely.
The industry has already geared towards that. Everyone is going to be doing that. So, we I remember in the early 90s when we moved to recovery and moved to 410 and everything else, there was an intimidation factor out there because it was unknown. So the biggest thing with this is, I think the more we learn about it, the more we understand it and what we have to do, we're hoping to take that intimidation factor away, because knowledge is key.
It sure is. One of the things that you had mentioned is we're actually at Heatcraft going above and beyond the required detection. Whereas, there's a required that if we hit that 25% LFL that we're required to go into mitigation. But you're actually going into like a pre-mitigation, like a warning stage beforehand, before you would ever get to that point, knowing that we got perishable products. We're actually going to have some indicator beforehand. Can you talk about that a little bit?
Yeah, that's correct, because first of all, I think the at 25% you have to go into the mitigation.
Hmm.
You've got a leak. If you've hit 25% of the LFL, okay, we have to go into mitigation. Of course, you have sensors in the coil to tell you that it's leaking. You've got an RDS system. Well, where one of the things that we're doing is we're giving you a warning at about 6 to 7% that it goes off and says, "Hey, there's a leak. You're going to have to address this." But now you've got some time
Exactly.
between when you initiate that leak response, which is nothing but a warning to say the equipment's still working, you've got a refrigerant leak, hey, go ahead and deal with this before you reach the shutdown. Because anybody that has dealt with critical refrigeration installation knows that anyone stands to lose a lot of product, or a lot of whatever it is that they've got in that walk in that's critical. It's nice to know that you're going to have a problem that you can deal with now before you lose that refrigeration, so that the customer's got time to deal with it.
Working in a lot of grocery refrigeration, we've had refrigerant detection sensors in the compressor rack rooms for decades. And I've always thought, boy, it'd sure be nice if we had these in our evaporators as well to be able to, look for refrigerant leaks before they become a emergency or a high priority. And so by doing that at that very low LFL, if there is a small leak, I mean, 6, 7%, that's a very small leak in a, contained space. So it's going to give us a lot of indication beforehand so that we have time to call, get on that schedule, get a technician out and determine where that issue is. And in many cases we find flares or things that are repairable with minimal downtime versus waiting until it's hit that 25% LFL and it shuts down our refrigerant flow and goes into mitigation. So,
Right. And of course, we, like you said, we've been using refrigerant detection systems for years. If you've ever worked in any enclosed environment, the basement of buildings, anything where there's been the possibility of accumulating refrigerant, they're already out there.
mhm.
We're just simply adapting them to go into our unit coolers, into the evaporators. So,
Mm.
it's not going to be any great leap in technology. It's just what a few little things that we're going to have to do differently. Because one of the things that we're doing is dual compatibility with our
Yes.
coils, as we call it here. What we're doing is that we're making the evaporators where they're dual rated. You can buy an evaporator, do a change out, use it for your existing A1 refrigerants, or you can buy that evaporator set up for the A2Ls. So with our intelligent control system, you can get it either already installed for the A2Ls with an A2L evaporator, or you can then add the refrigerant detection kit, simply plug it into the intelligent control. If you fail to put the RDS on and you try to select an A2L refrigerant, it's going to say, hey, I need the RDS kit. So it's going to
Mm.
tell you that you have to have it. So
Yeah.
that's going to make it nice, because rather than buying a piece of equipment and say, well, it's already outdated, we're going to be able to have that dual refrigerant capability with what
Yeah.
we're making.
I was fortunate enough to get a chance to take a look at that at AHR this year. And from a service technician, that's a dream come true for a product. Because if we look at, previous refrigerant generations, when we were making these refrigerant transitions, it was a significant change on operating pressures. So we would have one evaporator coil for the existing refrigerants that we were using and one evaporator coil for the new refrigerants and new metering devices. And so, like you'd mentioned, this isn't as significant as a change as we've seen in the past. It's just a little bit different. Because of operating on very similar pressures, we can utilize a coil that would operate on either. So whether I'm doing a new installation or whether I'm doing a coil replacement on an A1 refrigerant or a coil replacement on an A2L, I have one product that will fit all three categories.
Correct. Now, one of the things that I tell a lot of the classes that I teach and technicians that I run into is do your homework, because the contractors that do learn about this ahead of time. They educate their customers, because it's the end user that's going to be turning to them to say, hey, I need help here. What do I do? And let's face it, that our technicians that are out there in the field are usually the first point of contact with the customer. They're the one telling them, you've got a problem. Here's what's wrong. And the sooner you offer them a solution, because one of the things that we did when I was in the field is we had what we called planned obsolescence. We knew how old the equipment was. We kept a list of it with the customers. As we would make recommendations, you do your maintenance, you say, here's the list of things that could possibly go wrong with this. Here's what we're recommend doing. Because if they can budget for this ahead of time, it's going to make it a lot easier. And when you become the expert that your customer can count on, it's going to make your life and theirs a lot easier. So we try to provide as much information as we can. And that's kind of my job here, is to present the service tech's point of view, to us as a manufacturer, because
I,
I know what makes my life easier in the field and what I prefer to do and use.
I love that. That's the whole reason I've chose to be in this role is, from a technician perspective, how does these things look? How do these changes look? What do you need to know? So when we pair with equipment manufacturers like Heatcraft, who's trying to get the information out to the industry, all you need to do to be a successful contractor is to be educated, to understand the difference and present it to your customer. That's all we've ever really done. So I worry about the contractors that are going to struggle with this transition when they go to buy that first new piece of equipment and go, wait a minute, this looks different. What's going on here? Versus the one that goes, I've been waiting for you and I know that you're not that different. So come on, let's go do this installation.
One of the things that we're doing is creating a series of almost did you know videos that you will be
Mm,
able to access on our website to get this information out there. They're going to be in quick, easy to see modules. That's something that we're building. We're putting this out there to make the technician's life easier because information is golden. When you know going in what I'm facing, what I have to do, the intimidation factor goes away because I've always heard, oh, I'll retire before I have to face that change or do that. And technology is
mm,
changing at such a rapid pace right now. We have to keep up. And education is, that it's important to me. I've always been that guy that the technicians have come to that says, "Hey, what are we going to do?" And it was my job to get the information and find it. So that fits in nicely with my role here at Heatcraft.
yeah, absolutely. I really look forward to those videos. I'll be sharing them like crazy when we get to that point. So, Justin, tell us a little bit about the training that Heatcraft offers and how people can learn more about the training opportunities.
Well, first of all, you can visit our website and you can look at our training schedule. We do several things. First of all, we have training that, well, let me say this first. We're putting a big emphasis on training. Over the course of the next year, we're going to be
Mm,
building a new training facility here to greatly expand what we do. So we offer classes here at Stone Mountain, classes on our intelligent controls, our electronic defrost controls. We also offer basic education
mm,
because after being in the field, I realized that even students coming out of a tech school that are getting ready to break into the industry, they haven't really learned how to read diagrams and troubleshoot to the point that's really going to benefit them. So we offer everything from a basic refrigeration and installation to a troubleshooting course to specifics all the way up to CO2. And we're going to be developing classes for racks. And as time moves forward, I think we'll really be able to offer some nice in-house training, but we also take it remotely. I'll be traveling to Texas next week to do a 2-day training for some technicians through one of our distributors there. We've been traveling all over the country to put these classes on as we've had the request. And now what we're doing is we've got a new development coordinator that's taking our courses, breaking them down into smaller sections, putting them on our website so that people can go in and say, well, I got 20 or 30 minutes. I want to find out
mhm.
about this. And so that's really the direction that we're heading is to trying to get that information out there, make it easier for people to take it in small chunks and just not get overwhelmed with it.
Yeah, you're right. That's it. A little modular training. Take it in small chunks and take it as often as you need and as comfortable as you need when you have that time available. No, it's absolutely what we need in the industry. Well, Justin Bailey, technical trainer for Heatcraft, I sure appreciate you joining us. And for those that want to learn more, I encourage you to go over to the website, heatcraftrpd.com. Thank you, sir, for your time.
You're absolutely welcome. It's been a pleasure.